All right, and this is just exactly like the test here. So the first thing is to find the components, then we'll add them, and then we'll draw a picture of that sum, okay? So let's draw these components here. Notice I go to the right, and I go up. Okay. This is my adjacent side. This is 12 meters, by the way. That angle's 21 degrees. Dyslexics beware, right? Okay, and this is my adjacent side. This is my opposite side. So let's figure that out, right? For the first one, adjacent is 12 cos 21. 12 cos 21. Okay, so 12 cos 21 is 11. And it says carry 3 decimal places. So I'm going to go 203.203 because it's 202965. So 203 is rounded to 3 decimal places, right? And the opposite side is equal to 12 sine 21. That'll be smaller, right? That's 4.300. Okay, so my adjacent side, that's positive, and it's in the x direction. That's positive x, right? This is positive y. So this guy is positive and in the x direction, and this guy is positive and in the y direction. Okay, so let's write this down. 11.203, and this is 4.300. Positive, positive, x direction, y direction. Double check. Does that make sense? It does. Okay. So let's draw a picture of this guy here. So that's my opposite. That's my adjacent. So let's figure that out. The opposite and the adjacent. The adjacent is going to be, the magnitude is 8. That angle is 17 degrees. Right, so it's going to be 8 cos 17. The opposite side will be 8 sine. So let's figure this out. 8 cos 17 is 7.650. And then 8 sine 17 is 2.3389. So I'll say 2.339. Okay, so let's see. My adjacent side, this is positive y because it goes up, right? So that's positive and in the y direction. And then the opposite side here is going to be in the negative x direction because it's to the left. So this guy is negative and in the x direction. So this I'm going to put here. Most common thing, by the way, is you switch your x and y. So we'll double check that. And then this is 7.60, and that's positive in the y direction. So let's just do a double check here. This guy, I expect 2 positive components, and the x should be bigger than the y. And indeed, we have 2 x is bigger than y, so I think we're good. This guy is going to have a positive y, but a negative x. Positive y, negative x. The y is going to be bigger than the x because it goes up more than it goes to the left. And that is also correct. So chances are I have the right things here. Okay. Now I'm going to add these numbers. So I'm going to go 11.203 plus negative 2.339. And I get 8.864. Right, and I'm going to add these guys here, 4.3 plus 7.6. Oh, 6.5, sorry. That's a 6.5. Good thing I caught that. 7.65. And that's 11.95 in the y. Okay? Does that look right? That looks right. Okay, did I do that right? I'm just double checking my work. It's so easy to make like a small mistake. 4.3, 7.65, like this mistake, right? Oops, I missed the 5. Okay, so now we're good. This is to the right. This guy is up, okay, because they're both positive. So if I draw a picture of this guy, notice it's to the right. It's up a little more than it is to the right. So let's draw a picture. To the right a little less, sorry, than it is up, right? It goes up more, whoops. Oh my God, my shift key failed me. So it's going to be something like that, right? Okay, my magnitude is the square root of 8.864 squared plus 95 squared. Okay, so square root of 8.864 squared plus 11.95 squared. 14.87, so 14.9 meters is my magnitude. Okay, and then that angle there, theta, this side is 11.95. I expect it to be bigger than 45, right? 8.864. So that's going to be tan minus 1 of 11.95. That's the opposite side, right, over the adjacent side. Okay, so second tan of 11.95 divided by 8.864. Okay, so 53.4 degrees. Okay, so make sure that your vector is a nice arrow. It's pointing in the right direction. You've labeled which angle. You've found the angle. You've labeled the magnitude with not only the number, but the units. Don't forget the units. How sad would it be to lose half a point at this point, right? Okay, that's the answer.